When installing a meter center with a 1600 amp main switch, proper bonding and grounding are essential for safety and code compliance. This setup typically involves a main switch with 4 bus bars, 3 phases, and a neutral feeding through to meter stacks on each side. In this scenario, with 3 stacks of 4 meters each and individual 100 amp breakers for each user, understanding the correct grounding and bonding procedures is crucial. Bonding should occur at the main switch. Specifically, the neutral bar at the main switch must be bonded to the ground bar. Additionally, a bonding jumper should be installed between the ground bar and the meter center enclosure to ensure electrical continuity. When it comes to grounding, it is important not to install an earth ground at the meter stacks. The equipment, as designed by the manufacturer, typically does not provide a provision for earth grounding, and furthermore, it is generally not required for this type of installation. There are several reasons for not installing an earth ground at the meter stacks. Firstly, the neutral conductor serves as the return path for current and provides a lower impedance connection to the electrical ground. Secondly, installing an earth ground at the meter stacks would create a parallel path for current. This parallel path could interfere with the proper operation of the main switch and overcurrent protection devices. Thirdly, the absence of an earth ground at the meter stacks is not considered a safety hazard, provided that the neutral conductor is properly bonded to the ground bar at the main switch. To further enhance safety and code compliance, consider these additional factors. Firstly, use insulated neutral bars in the meter stacks. This helps to separate the grounded neutral conductor from the earth ground, preventing unintended current paths. Secondly, the 100 amp breakers serving the individual user should ideally have a ground fault circuit interrupter or GFCI function. GFCI breakers can detect small imbalances in current and quickly trip to prevent electrical shock. Thirdly, ensure that the entire meter center is properly grounded and meets all applicable electrical codes. This includes verifying the integrity of all grounding connections and adhering to local and national electrical standards. In summary, the key steps for grounding and bonding at the meter center are: firstly, bonding the neutral bar to the ground bar at the main switch. Secondly, installing a bonding jumper between the ground bar and the meter center enclosure. And thirdly, avoiding the installation of earth grounds at the meter stacks. Remember that the neutral conductor serves as the primary return path and is bonded at the main switch. Adding earth grounds at the meter stacks can create undesirable parallel paths. These practices are in line with standard electrical codes and practices. They prioritize safety and the correct operation of overcurrent protection devices. Always consult the latest edition of the National Electrical Code, the NEC, and local electrical codes for specific requirements and updates. It is also beneficial to consult with a qualified electrical inspector to ensure that the installation meets all applicable regulations. The proper grounding and bonding of a meter center are crucial for protecting people and equipment from electrical hazards. A properly installed system ensures that fault currents have a safe path back to the source, allowing overcurrent protection devices to quickly trip and energize the circuit. It also minimizes the risk of electrical shock by keeping conductive surfaces at or near ground potential. Improper grounding and bonding, on the other hand, can create dangerous situations. Fault currents may take unintended paths, leading to overheating, fires, and electrical shock hazards. It can also interfere with the proper operation of sensitive electronic equipment. Always prioritize safety and code compliance when working with electrical systems. When selecting materials and equipment for the meter center installation, it is essential to choose products that are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or UL. This ensures that the products have been tested and meet established safety standards. Use appropriate wire sizes and types for all grounding and bonding conductors, following the requirements of the National Electrical Code, NEC. Ensure that all connections are clean, tight, and properly made. Use approved connectors and tools for making grounding and bonding connections. After completing the installation, thoroughly test the grounding and bonding system to verify its integrity. Use a ground resistance meter to measure the resistance of the grounding electrode system. Verify that all bonding connections are secure and have low resistance. Also, inspect all wiring and connections for any signs of damage or loose connections. If any problems are found, correct them immediately. Finally, keep accurate records of the installation, including drawings, specifications, and test results. This information can be useful for future maintenance and troubleshooting. In addition to following the specific grounding and bonding requirements for the meter center, it is also essential to follow all other applicable electrical codes and safety regulations. This includes requirements for wiring methods, overcurrent protection, and equipment installation. Always work safely and use appropriate personal protective equipment, such as gloves and safety glasses, when working with electrical systems. If you are not qualified to perform electrical work, hire a licensed electrician to do the job. Remember that electricity can be dangerous, and it is always best to err on the side of caution. Grounding and bonding are critical components of electrical safety, and it is essential to understand and follow the proper procedures. This information provides a general overview of grounding and bonding requirements for meter centers. However, it is not a substitute for professional advice or training. Always consult with a qualified electrician or electrical engineer for specific guidance on your project. Furthermore, staying updated with the latest revisions to the National Electrical Code, NEC, and any local amendments is crucial to ensuring compliance and safety in electrical installations. These codes are periodically updated to reflect new technologies, safety practices, and industry standards. Regular training and education are essential for electrical professionals to remain current with these changes. Consider attending workshops, seminars, and online courses offered by reputable organizations to enhance your knowledge and skills in electrical grounding, bonding, and safety. In addition to technical expertise, effective communication is also vital in electrical work. Clearly communicate with other members of the team, including electricians, inspectors, and building owners, to ensure that everyone is on the same page regarding the project requirements and safety procedures. Document all communication and decisions to create a clear record of the project's progress and any changes made along the way. Furthermore, promoting a culture of safety is essential in any electrical work environment. Encourage workers to report any potential hazards or unsafe conditions without fear of reprisal. Implement regular safety meetings and training sessions to reinforce safe work practices and address any concerns. Provide workers with the necessary personal protective equipment and ensure that it is properly used and maintained. By fostering a strong safety culture, you can minimize the risk of accidents and injuries on the job site. Finally, remember that electrical work is a complex and ever-evolving field. Continuous learning, attention to detail, and a commitment to safety are essential for success. By staying informed, following best practices, and promoting a culture of safety, you can help to ensure that electrical installations are performed safely and reliably. The procedures outlined previously regarding bonding at the main switch, avoiding earth grounds at the meter stacks, and using insulated neutral bars are designed to prevent circulating currents and ensure that the intended ground fault path is followed. These practices also help to minimize the risk of voltage differences between different parts of the electrical system, which can be a safety hazard. When dealing with a 1600 amp service, the consequences of improper grounding and bonding can be severe, potentially leading to equipment damage, fire, or electrical shock. Therefore, meticulous attention to detail and adherence to established codes and standards are paramount. In addition to the technical aspects of grounding and bonding, it is also important to consider the administrative and regulatory requirements. Obtain all necessary permits and approvals from the local authorities before starting any electrical work. Coordinate with the utility company to ensure that the service is properly connected and metered. Comply with all applicable environmental regulations, such as the proper disposal of electrical waste. By addressing both the technical and administrative aspects of the project, you can help to ensure a successful and compliant installation. Remember that the information provided here is intended as a general guide and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer for specific guidance on your project. They can assess the specific conditions of your site, evaluate the applicable codes and standards, and recommend the best solutions for your needs. In the state of Massachusetts, electrical work is regulated by the Board of State Examiners of Electricians. The board licenses electricians and enforces the Massachusetts Electrical Code, which is based on the National Electrical Code, NEC, with some state-specific amendments. Before undertaking any electrical work in Massachusetts, it is important to ensure that you are properly licensed and familiar with the state's electrical code. The Massachusetts Electrical Code contains specific requirements for grounding and bonding, including requirements for grounding electrode systems, equipment grounding conductors, and bonding jumpers. It also includes requirements for ground fault protection, surge protection, and other safety measures. Always consult the latest edition of the Massachusetts Electrical Code for the most up-to-date requirements. In addition to the state electrical code, local municipalities may also have their own electrical codes and regulations. It is important to check with the local building department to determine if there are any additional requirements that apply to your project. The local building department can also provide information on permit requirements and inspection procedures. Furthermore, the utility company may have its own requirements for connecting to the electrical grid. It is important to coordinate with the utility company to ensure that your installation meets their requirements. The utility company can also provide information on metering and billing procedures. By complying with all applicable electrical codes and regulations, you can help to ensure the safety and reliability of your electrical installation and avoid potential penalties. In conclusion, grounding and bonding are critical aspects of electrical safety and code compliance. By following the proper procedures and consulting with qualified professionals, you can help to ensure that your electrical installation is safe, reliable, and compliant with all applicable regulations. It is essential to stay informed about the latest electrical codes and standards and to continuously improve your knowledge and skills in electrical work. Only properly trained and licensed individuals should undertake electrical installations to prevent hazards and ensure compliance. Remember to use appropriate tools and safety equipment, and always prioritize safety when working with electricity. Doing so will help protect lives and property from the dangers of electrical hazards. By adhering to these best practices, electrical professionals can contribute to a safer and more reliable electrical infrastructure for everyone. Furthermore, documenting every step of the installation process is crucial for future maintenance and troubleshooting. Detailed records of wiring diagrams, equipment specifications, and test results can be invaluable when diagnosing and resolving any issues that may arise. In addition to technical skills and knowledge, strong communication and collaboration skills are also essential for electrical professionals. Working effectively with other trades, such as carpenters, plumbers, and HVAC technicians, is crucial for ensuring that electrical installations are properly integrated with other building systems. Clear communication with clients is also important for understanding their needs and expectations and for providing them with accurate and timely information about the project. Moreover, ethical conduct is paramount in the electrical profession. Electrical professionals have a responsibility to uphold the highest standards of integrity and to act in the best interests of their clients and the public. This includes providing honest and accurate information, avoiding conflicts of interest, and complying with all applicable laws and regulations. By adhering to these ethical principles, electrical professionals can earn the trust and respect of their clients and the community.